building the rotating assembly and putting file to fit rings in a small block Chevy for a oval track application. So it tends to have a little bit looser end gaps in it. I'm going to get started with spotting the ring into the #1 piston hole, and then just to get a pretty accurate reading, I'm going to use the piston and just push it down to the oil rings so it's aligned in the cylinder wall. This block has a fresh bore because the rotating assembly came in a oval track car, and I'm trying to get that oval track motor back together for this season coming up. It's good to keep track of how many rotations you do. This is a rebuild with fresh parts. I'm going to put new rod bearings in. The mains seem to be alright. Had a little wear on the rod bearings though. So this here Summit Racing device is a ring grinder. So keeping track of the rotations, of course, just 1, 2, 3, 4, 5, 6, 7, 10, so on. You don't have to count it out loud, really. You can probably do it yourself, but for the video's sake. Take just a little bit of the bore off with a fine finished file. Hoping that's going to be alright, because it was close. Didn't look like it needed much. You don't want to scratch that cylinder wall while you're playing around with this stuff. So, let's see where we're at. And then plus that ring's just in the same spot each time you go to put the fuel gauge in there. So, it's a little tight, but it says 28 to 30 on the chart I got from the guys down at On Track. So there we go. There's the top rings ready. So let's just double check. We don't want to go grinding on something we don't know is going to be the right size yet. So. Should be about the same, so we'll do 10 on that one too. Trying to keep about the same tension if you can, because if you push harder then you're going to take more off of it, of course. This one seems like it needs maybe 1 or 2 more. It's still really tight. I had a little fumble on the beginning of that grind, so. Let's see where we're at. And then most of the motor should have had about the same wear like that, so I should be pretty close to doing about the same thing around all the rest of the cylinders. Yeah, feels pretty good. Alright, getting ready to put this piston back in its hole. It's always good to line the gaps in the rings from top and second, and with the oil rings as well, across from each other for compression issues, or keep from having compression issues. I've got a couple of pieces of hoses on the end of those bolts down there, so I don't take a chance of scratching up any of the crankshaft down there. So, once you have your rings where you think you like them, go ahead and set that down in the hole. It's a pretty basic ring compressor. Once you start getting it a little snared on it, you want to raise it up just a little bit so you make sure you get that bottom oil ring. And then basically just some gentle taps down and in. Got the crank so it'll go all the way down, so there we go. So I'm going to go ahead and do some assembly lube, and nice generous amount in there, and turn that over and lubed up the rod cap. This particular setup has printed numbers on one side of the rod, so it's helps it to where I know which side is which. And as I disassembled the old block that had a crack in it, I just wrote on the top of the piston or which side I wanted at the top. So it helps because you don't want to get those backwards on there, because you can get some clearance issues with the crank itself if you get some of them caps backwards or get the rod in there on the wrong direction. So I'll go ahead and tighten this up, and then we'll go into torque mode later when we go ahead and start torquing everything down, but we'll just get it assembled for right now. This little thing shouldn't give too much tension on it, but just get it closed. There we go. Number one's all the way in, top to bottom. I forgot to mention during piston installation that it's good to take a rag and a lightweight motor oil, 10 weight, something like that, and wipe down the cylinder walls when you go to do that installation. If you've noticed, I've already put on the timing chain, and I've installed the cam and put a bunch of assembly lube on that, nice and generous. The top gear bolts are spec'd with Loctite to be at 20 pounds with the torque wrench, and then torque the rods to 45 pounds. And then the insides on the mains are 70 pounds, and the outsides for the 4-bolt main are 65 pounds. So next I've gone ahead and cleaned up my timing chain cover, but when I was scraping the gasket off, I popped part of this metal apart, so I drilled some little holes through the part that was loose and then just welded it through it. So I'm cleaned up and ready to start putting that together. I went to the parts store and got a gasket set for that from Felpro. It comes with a sleeve for the harmonic balancer and a new seal and a new gasket. So that's what I'm getting ready to do now. If you're upgrading or replacing the timing chain in a small block Chevy, they typically come with 2 dots, one on each gear, that you need to line up between the crankshaft gear and the camshaft gear to be at the right timing. Well, I've got the timing chain cover on, marker for the top dead center on number 1, harmonic bouncer in. I can't seem to find the drive shaft for the oil pump, so I don't think I'll be getting that in quite yet. I gotta figure out something or dig into some more stuff, but I've finally gotten to the part that's going to be the dirtiest part of this build. And just to show you guys where this old tired motor came from, here's the oil pan off of it that I gotta finish cleaning up and get ready to put this back together and be able to seal it up. Okay, I've gotten a few more things done. I've got the oil pump in because I replaced the drive, and I'm happy that I kind of lost it, but there's a little plastic holder that holds the drive into the oil pump, and that's what I found inside the pickup tube when I was cleaning it up, and could have been the results of why this block spun a bearing. So I'm glad that it's got a metal collar for that, and I went ahead and torqued that down at 65 like the outside main caps for torque, and I opened up the oil pump and I squeezed it full of about halfway with assembly lube, so it gives it kind of a suction when it first cranks over, so it'll draw all the oil up into the motor faster. And when you put those back together, they say to torque them between 80 and 105 pounds, so I decided 90 because I don't want to break anything at this point. I've been known to do things like that, not knowing my own strength. Well, I've had it turning around. I put the mechanical fuel pump in that I'm going to run in the oval track car. The shaft wants to fall down all the time, so it's easier to install while you can have the motor up on its side. So the torque for the small bolts was 20 and the fuel pump itself is at 35. So a little bit of diesel fuel and a little bit of scrubbing, we're able to clean up that pan. Looks quite a bit better now. It's not perfect for sure, but I'm getting ready to install that now. So it's the first time I've used a single piece oil pan gasket, and it seems to have worked out pretty well. I think the bolts seemed like they were a little short at first, but once it got to start tightening down, it seemed like it was alright. I got a nice clean line with the gasket sealer, so you don't really want to use too much of that to start getting it oozing out of everywhere. You just need a nice little thin layer. So we're all sealed up now on the bottom end, and the last thing I need to do to this to be ready for heads is I'm going to take a 7/16 by 14 threads per inch tap and clean out all of the head bolt threads. Put a little bit of assembly lube in that so it's ready for a set of heads, and hopefully soon enough I'll be able to get this in the car and be able to have a part 2. But just to recap everything we've done with this, so this was a stock 8-to-1 motor, and I spun one of the rod bearings at a KBPI car show burnout competition. So the race car came with a motor that had a crack in 6 and a flat lobe, so I off the block and kept the rotating assembly, and after I spun the bearing in this, I had it machined and got it ready to accept that rotating assembly. That's a 10-to-1 that's set up for oval track racing. It's got a new cam now, it's got a dual timing chain, it's got a new flywheel, it's got CT1 coated rod bearings that are new, file to fit rings, and I don't know, what else can we say? Maybe we'll have a part 2 when we go from the heads up and get it in the car and break it in. Thanks for watching.